Alright, let's move into problem number 12 now. So let's read out the problem. So problem number says that it defines the triangle number. So triangle number is 7th triangle number, meaning 1 plus 2 plus 6 up to 7. Just add from 1 to 7 and that becomes 28. That's the 7th triangle number. So if you just continue like that, the first 10 triangle number is becoming like that. 1, 3, 6, 10, 15, 21, 28, 36, 45 and 55, etc. Now we have to, what we are trying to do is we are trying to find out the factors of this number. Let's say factor of 1 is 1, factor of 3 is 1 and 3, factor of 6 is 1, 2, 3, 6, like that. Okay. If you look at here, we are considering the first number and the last number as a factor. For example, 28, we are considering 1 and 28 also as a factor, and remaining 2, 4, 7, 14, 28. So basically, and 28 has 1, 2, 3, 4, 5, 6 factors, okay, which is more than 5 factor. So the question, it says 28 is the first triangle number who has over 5 divisors. Now, what is the value of first triangle number to have over 500 divisors? Over 500 divisors, okay. So what we have to do is, first we have to define a function which generates the triangle number. Then we'll basically create another function which will give us the number of divisors, okay, and then we should be able to do it. Okay, let's move on. So I'll just write down problem number 12. Okay, I'll add some more space here. Okay, so let's create a first triangle number definition. We know the triangle number has a formula, right? So 1 plus 2 plus 3 up to n is equal to, formula is n into n plus 1 divided by 2. Okay, so that's the formula. So we'll just use that same formula to define the triangle number. So define get trng number. Okay, so let's take the number and we'll return number multiplied by number plus 1 divided by 2. Yeah, that should be our triangle number definition. Let's check it. Get triangle number, let's say 7, so that's 28. Okay, 6, 21. So you see these numbers matching here. Now we'll have to create a function which will give us the number of divisor. So how we can get it? Let's define that function as well. Define get number of divisor. Let's do it like this. Okay, so we'll take number as num, then let's say number of divisor is equal to 0 or 1. Okay, it doesn't matter, let's give it as 0. Then for I in range. So we know, in order to get the number of divisor, we don't have to go until the whole number. Probably we can go until half of the number and that should be enough. Okay, and we don't have to start from 1, we can start from 2. So what do you mean by this? If we just do this number and we'll just do integer division of 2, and you know, if number is odd, this will give me, for example 5, this will give me 2. Okay, but I want to check until 3. I just want to check one more. So it should be n divided by 2 plus 1. Okay, that's how we'll keep our loop. Then we want to check if the number is divided by, that means the modular division I equal to 0. We'll just increment the number. Okay, number of divisor plus equal to 1. Just increment the number, and finally we just return. But you know, in this way, what will happen is we are not considering that number and the end number. So for 28 we will not consider 1 and 28 with this, but we actually want to consider this as per the definition. So that's why we know that there will be always 2 extra. So we'll just want to return number of divisor plus 2. Okay, and that should do our job. So let's check the number of divisor. Okay, get number of divisor. I'll just try with 5. 5 is only 2 because there is no other divider. 5 is a prime number, so it has only 1 and 5. Okay, if you give 6, that becomes 4 because it has 2 and 3 plus 1 and 6. So like that. Here it becomes 3 because it has 1, 9 and 3. Okay, so looks like that is working. Now what we also want to check is, let's check certain things. For example, I want to check the, let's check the gate triangle number. Okay, gate triangle number of let's say 9. So triangle number of 9 is 45. Okay, now if we check the gate, now we know that triangle number of 9 is actually 9 multiplied by 9 plus 1 divided by 2. Okay, that's 45. That's how 45 comes. So basically 45 is, triangle number 45 is 9 and 5, and if we get, okay, let's check it. I believe if we just get the divisor of 9 and divisor of 5 and multiply them, that will be equal to the number of divisor of 45. So let's check that, let's test that. So get number of divisor of 45, let's say, so that is 6. Now let's check get number of divisor of 9 multiplied by get number divisor of 5, that is also 6. Okay, let's try with another number. Let's try with, let's say next number is 55, and 55, you know, it came because 11 plus 10 divided by 5. Okay, so that means, so what is the number of divisor of 55? Let's check it. So it's 4. Okay, and if I just do it like that, 11 and 5, that is also 4. So I think you get my point. So this is working. That means we don't have to do the number of divisor of 55, because that way our condition will run forever. Yeah, it will have performance impact. So instead what we'll do, we'll just get the number of divisor of this multiplied by this, and that should do our job. Okay, now let's just finish it off. Okay, now let's create a loop. But one thing we must know, if this number is n, that means if n is integer, n is even, then we want to divide that even number. But if n is odd, then we want to divide n plus 1 divided by 2. What do you mean by that? Let's create a loop. Okay, let's create our coding. Let's say I initialize a number is equal to 0, then I initialize number of divisor equal to 1, then let's get this size variable is equal to 5. Size, basically I want to get the maximum number of divisors, that's the number of divisor size. Okay, and I'll write down a while loop, while n number of divisor less than size. Okay, now if, now you know, if number is even, actually you should start it from 1. Okay, if number is even, this is our number. If number is modulo division 2 equal to 0, that means if number is even, number of divisor is equal to get number of divisor is number of div num divided by 2 multiplied by get number of div num plus 1. Why is that? Because number is even, so I want to divide that number divided by 2 and multiplied by number plus 1. Otherwise, that means if the number is odd, then I want to do it opposite. Okay, so let's copy this. It will be like num multiplied by num plus 1. I have to get another bracket here, divided by 2. Okay, and then increment number plus equal to 1. Okay, this is else. Okay, now so I gave the size as 5, and let's see what num came. So num came as 8, but ideally it should be 7. If you look at that, it says the 7th triangle number is the first triangle number where number of divisor is more than 5. So in our logic, it's just counting on to 8. So if I just reduce it by -1, that should be okay. And by the way, let me try with this. Still giving me 8. Fine, because we are just running one extra loop, so that means our ultimate number should be number is equal to number minus 1. Okay, so that should be our answer, and answer to the target triangle number position. So if number of divisor, we want number of divisor to be more than 5, then our answer should be 7. Okay, but in our case, what is the question asking? Question asking is number of divisor more than 500 over 500 divisor. So that means in our case size will be 500. Okay, so what is the number came as this. Now if I reduce the number will be like this, and what we have to answer is what is the triangle number. Okay, basically we have to tell what is the value of the first triangle number. So what is the value of the first triangle number? That means we have, our answer should be the triangle number of this. So let's call our function get triangle number of this. Okay, so this should be our answer. Let's check it out. Yeah, that looks correct. Okay, that's it for the current version. Okay, thanks for watching. Again, coming up next is problem number 13. If you like my video, please like, share and subscribe. Thanks again for watching.